Hello. Wow. From the moment I sat down to right now, there is a lot more people. Now I feel the pressure. Thank you. Oops. So I'm still getting used to my new laptop. I bought it for Christmas. It was a recommendation from my accountant. It's not that he knows anything about laptops. He said, if you don't buy stuff right now, the VAT is going to crack you down. And it's like touch, and everything goes super messy sometimes. And I am usually like point to my screen when I'm explaining stuff, and I move my objects around, and it gets very, very messy. And when I do like this, it's not showing up. Wait. Let's do it again. Yeah. Pretty, yeah? So my name is David Cuartielles. I'm officially from Sweden. I know I really don't look like it. It's because I was born like somewhere else. But I moved here 13 years ago, and that's 1/3 of my life, so I think I can legally be considered a Swede, even though I refused my right to get a passport. Because, you know, you have to be a bit of an anarchist if you are in this business. So anyway, I am one of the founders of the Arduino platform. I don't know how much you know about it, so I will introduce you briefly to it. Yeah, in the years later, I can talk to you about what is the Arduino company structure, which is very complicated. That is definitely not worth your patience right now. But at the same time, I am the CEO of something called Arduino Verkstad, which is, Verkstad means like mechanical workshop in Swedish. So I run a company here in Sweden, and we do a lot of user-centered design. And I am an assistant professor at Malmö University. So if you don't do all these things in life, I mean, life isn't really worth it anything. And of course, I also have a cat and a kid and a wife and stuff. Then, like most of you, I think there is a girl in the audience, so you might have a husband or two instead of a wife, or boyfriend, or a dog, which is the same thing. Anyway, I came to Sweden to work at Malmö University. I didn't come here. I mean, I used to work as a microchip designer at Infineon. Just to get you a bit of my life story, since I was like 5 years old, I had like a real clear path in life. I want to be an engineer. I started by blowing up fuses at my parents' place, like burning my Commodore 64 multiple times, trying to plug in LEDs in the wrong ports and getting capacitors to explode in my hands and stuff like that. It was a fantastic, fantastic childhood where my dad had a lot of fun looking at me without being hard. Because if you sit in the sofa, nothing can happen to you. But if you're the one in front of the power plug, anything could happen to you. So the thing is, I've been always fascinated by the idea of how technology changes over time. And I like this slide very much because it shows you the evolution of the mobile phone. Like from being a tool for early adopters and actually people with a lot of cash to become something that is in everybody's hands. And it's actually in everybody's hands because it's so light that even a baby can't, you know, carry around an iPhone. They can probably not set up phone calls to the right people, but they can do a lot of stuff out of them, including watching porn. But accidentally, of course. Yeah. I mean, I'm not sure they are browsing those things by themselves. Anyway, the point is that there's always a time when technology reaches the hands of everybody. You know, in the beginning, technology is for us, the geeks. We try it out, we put it under a lot of stress, we make sure that it breaks only when it has to break, and then all of a sudden comes a time when your mom is having that thing that you were playing around with 4 years ago. And then is when it gets interesting and dangerous at the same time. So when I was working at Infineon, I was invited to make a lecture at Malmö University. Don't ask me how it happened. But it happened. And it's an art and design school. And they asked me, would you be interested in teaching Java to the graphic designers? And I was like, fuck, what is a graphic designer? I knew what Java was. I mean, and but I also thought like to myself, okay, I have never programmed in Java. I knew C, C++, Pascal, you know, that fantastic ancient languages like knowing Latin nowadays, and basic in multiple forms, assembler for Commodore 64 and for PC, and VHDL, and I can't go on. And somebody tells me, can you teach Java to graphic designers? And it was like, wow. It's like, you know, going to an island and living with the aboriginals for a while. I thought to myself, well, I'm 25. I mean, there is always time to go back to design microchips at some point. I was really wrong. I will never go back. And after a couple of years teaching Java to designers, which meant I had to completely change my mindset in how you explain stuff. I mean, you don't go and talk to people about classes and objects just like that. You wake up, cup of coffee, you know a class. No, it's not working like that. Somebody asked me, would you be interested in teaching electronics to designers? And I was like, wow, that's mind-blowing. You know, it's like, I've been like making light bulbs explode since I was a child. I mean, I want to see other people burning stuff, you know. So I had this idea of like, what if we design something like this? And I started in 2003 to design boards that designers could use. And we were using something called Basic Stamp. I don't know how familiar you are to Basic Stamp, but it was a fairly expensive prototyping platform that was made in the United States, and it would take us weeks to get it to Sweden. And it would take like hours to make something like this by the students in class. So they would make their own prototyping platforms, and they would make crazy stuff. And since everything is about mobile nowadays, I'm going to show you what 3 design students thought about in 2004 that you could do with mobile phones. Something like this. It's called the Alcophone, or Alcontrol. And it's fascinating because they came with the idea that when you go out, the long wire on the thing is a breathalyzer, and it goes back to one of those boards you saw earlier, and a computer, and the computer sends like your level of alcohol in blood to the internet. And through MoFun, that is like a Russian programming language for making computer games for that particular phone, you could download through GPRS your level of alcohol in blood, and it will allow you controlling your phone agenda. And then you would decide, okay, if I'm not drunk enough, I'm not going to call Peter, because Peter is a bastard, and I only meet Peter when I'm drunk enough to, you know. He's my drinking buddy. On top of that, the more drunk I get, I really don't want to call my ex-girlfriend. It's going to get very messy. And the more and more drunk you get, you start to like take out people from your list. At some point, you only want to call like a trusted taxi driver or ambulance. It depends on. So the whole idea behind this concept was basically to bring in some aspects behind Swedish social drinking values. And I'm sorry for those of you that are from Sweden, but this is very, very sad. You know, people need to drink to talk in this country. They do it in my class. You know, it's like I asked them a question. Yes, teacher. But it was a very interesting concept. So we pitched it to Sony Ericsson. Sony Ericsson laughed at us and said, you know how many people come here willing to make a breathalyzer in the phone? And it's like, okay. You know, LG took the idea seriously, and they make 150,000 phones in like a month or something. So, I mean, I have the slide about that, but I'm not going to show it to you, but because it's embarrassing to show it in Sweden. Anyway, the thing is that making things like this brought us to the concept of like, we need a prototyping platform that doesn't take weeks to bring from the States, that is cheap, so if anything breaks, the students can fix it. And that's what made Arduino. You know, we spent all this time. I was in Sweden, my partner Massimo was in Italy. I had a similar experience with industrial design students in Italy. So the question is then, what is Arduino? That space I made, it was for the fact, but I didn't want to say it in front of you. I said it. So Arduino is made of circuit boards, and it's a mistake when people think like Arduino is only circuit boards, because without the story I told you, Arduino is nothing. It's just yet another prototyping platform. It's something that is designed for art and design students to just plug things wrong multiple times and not catch fire. You know, we didn't want to get the experience I got when I was 9 years old and actually got my Commodore 64 in flames, because I was just plugging things like, you know, I want to experiment. What happens if I put a capacitor between these 2 pins and stuff? You know, not everybody wants to do that, you know, but not everybody is ready to embrace the pain when it explodes in your face. But so it's a platform, and a platform is made of multiple stuff. And one of them is hardware. The other one is the software you need to program that hardware, because in essence, as you know, Arduino is a microcomputer without a screen, without a keyboard, without anything. So you need to make software somewhere else. And then you need a lot of documentation. You know, prior to Arduino, if you wanted to make something, microchips were very cheap. As a matter of fact, as a student, you could ask for samples to different silicon vendors. They would send you the samples. But then you have to buy the programmer, you know, you have to buy the compiler, you have to buy the books to read about it, and you have to have a lot of time to learn about it. our idea was that it should be a 5-minute experience. It should be almost like an Apple experience. You take it out of the box, plug it to your computer, and it works. And it's like that 90% of the time. It doesn't work if you have a Toshiba laptop with Windows 7 or Vista, where you have to do some stuff, which means I don't really like Toshiba. I don't really like Windows Vista. But when we made things like that, what happened is that it became very, very easy for people to start using it. So we grew up a community of users out of nowhere. To be honest with you, in 2005, when we made the first boards, Massimo and I were thinking, we just want to make a platform for our students to get a competitive advantage out there. You know, the design and art business is super tough. So a new skill like electronics would be great for these kids to have. You know, they would go out in the market, and they would be able to talk to engineers, and would be able to talk to the other designers, and, you know, build new good stuff. And like we make our first boards, we just make a website with a hand holding a circuit board like this, nothing fancy, and said, you know, this guys is open source, just get it and use it. And suddenly people started to order stuff, and we didn't have a store, we had like no plan, nobody wanted to make a company out of this thing. So up to 2010, for 5 years, we were basically letting somebody else take care of the business. We were just teaching, having fun, getting kids, cats, and girlfriends. Then we broke up with the girlfriends and made a company. So Arduino expanded all over the world. This is like distribution by continent of people accessing our website. This goes back to 2011, but it's very constant since 2011, actually. It has to do with how people connect to the internet and with the fact that our website is in English and Spanish. The day we make it in Chinese, we're going to rock the house, but that's not the case right now. So the flagship of our design is this one. It's called Arduino Uno, but it has only 14 input and output, digital input and outputs, and 6 analog inputs. So people start to complain and say, I want more pins, so we make one with 54 pins. I want Bluetooth, we made one with Bluetooth. We want something you can use for wearable computing. You can stitch to fabrics. That round one is Arduino LilyPad. You can stitch to fabrics. Something that has Ethernet, something that has Wi-Fi, something. Everybody needs something. What we need is love. So in order to get love from the community, we started listening to people, you know. And we always make this joke. If somebody says, like, could you make Arduino pink? If 1,000 people said we want a pink Arduino, we'll like go straight to make a pink Arduino. Please, make a campaign in change.org asking for a pink Arduino, so that we're making one. My daughter will be in love with you. But basically, our mission in life is to help people create with technology. So we are not so interested in the industrial environment yet. We're basically interested in how users react to these tools, how they can build with stuff, they can build stuff out of this stuff. And that's very, very important. So we are the geeks that work with the users. They are the geeks that make the technology work. So it's a different relationship we have to establish with people. So basically, we are what people call the makers. So makers is like the, let's say, politically correct word for hackers. You know, you can go around saying, I'm a hacker. People look at you and say, oh, by breathing by my side, are you reading my email already? You say, I'm a maker. They said, oh, it's great. Can you help me stitching this thing? You know, you get a different reaction from people when you say you're a maker. So we decided to say we are makers. But basically, it's the same ethics that applies. We make things, we prove that things work or don't work, and we share our results with everybody. So everything we do is open source. That said, I want to show you a video so you get an idea of the funny things you can do with Arduino. Oh, I forgot to say I need audio, but I make the sound. Brum, brum, brum. Brum, 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 brum. Brum, 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 brum. Basically, this was made for a TV ad for Chevrolet. We were commissioned to make a robot car, and we only had 9 days. So we made fun of Google in 9 days. By the way, is there anybody from Google in the audience? Because I saw there was people from Google. Okay, because I will keep on making fun of Google for a while. So, I mean, if you want me to stop talking about Google, they should buy us $100 million now. So Arduino is a lot of stuff, but you will see a lot of robots made, especially in education environments. So we design our own robot at some point. That got a little bit expensive, so we're looking into making cheaper robots, like something called the Clarabot. And again, robots are like super trendy. I hate robots. So when I listen about robots, I get like this, worried. There is other things people do, like very large light installations, like this one that I was designing in Jakarta for Nike just before Christmas. It's 100 meters long light installation with 40 Arduinos in a network and about 40 sensors. So when you run underneath it, the light follows you as you run. Like we could say like 90% of the open source 3D printers started with an Arduino board. This is a design that we made in Malmo with our own modification of a Prusa. And we also do a lot of curriculum for schools. We do a bit of an alternative kind of looking at technology. So we want to teach them about mechanics, complex mechanics, you know, like these videos about robots from ARPA that they walk on 4 legs. So we make like the funny drunk clown, as you can see in this video. As you can see in this video. And then we teach right now that we jump from teaching university students to teach high school students. But it's really hard to work with high school students, mostly because they are really remotely located. So we work with teachers, so the teachers can work with the kids. And we try to provide super high quality content, not like the classic, you know, tend to be extremely boring and old fashioned. And what we then look is at what people do. Like, for example, the outcome of one of our projects is a fair, like this one, where 400 kids come together and they show what they do. I'm totally in love with this cat, even though I don't really like cats, but it's a cat that gives you a flyer for a conference. So this girl had the idea. So when you step in front of the cat has a small magnet in the palm and it goes like this. There's paper clips on every flyer. So when it lifts the leg, it gives you the flyer. And it's strong enough to just lift one paper. So the amount of love this girl had to put to design this thing, you know, by herself, being 15, you know, is very interesting. So you have to pause with kids. So I'm here to talk about the Internet of Things. I just briefly run you through what is Arduino, and I have to talk to you about what is the Internet of Things from our perspective. And as I told you, I'm not just a company owner, I'm also a researcher at the university, so I research about this topic. So now I'm going to give you the super boring academic talk about Internet of Things, so get ready. Do you bring your pillows from the room? Yeah, a second of time. Just look at this slide, we will come back to it. So what is the Internet of Things? I like to talk about the Internet of Things talking about an alarm clock. I use this talk a lot of times. I did it the other night on national TV in Spain to try to explain people in the night show, when people are very tired, what is the Internet of Things? Because Internet of Things in the end is just nothing but the manifestation of machine-to-machine applied to everyday people. The idea that, you know, devices talk to devices and they help making our lives easier. So I always talk about an alarm clock. I like to take the metaphor of my grandmother, who is 90 years old, and we live in a city where there is only 50 days of clouds in a year. But it gets very cold, but it's sunny. So you look through the window and it's like, wow, it's a perfectly sunny day. And then you come down and it's -5. You know? And this becomes a problem when you get old because you're not really aware of seasons, especially Alzheimer helps a lot in this direction. So we have this idea of like, what if, you know, the alarm clock, which is the only digital device my grandmother has, the only one she's been looking into since TV, because she was born before digital, I have to say that. What if that could tell her about the weather? Well, if you start to analyze that, you will realize that it gets very complicated because you need this watch to be intelligent, but you need this watch to connect to the internet. And then go tell my grandmother she needs to pay a fee to get this thing to talk to the internet on a monthly basis. You know, that's one of the most challenging parts. In the IoT, things need to connect. And we tend to forget about it because we are connected all the time. But a super large sector of population, they don't understand connectivity. You know, I was having a conversation with people at Google that have a problem because all their business is browser-based. And when you go to, for example, Indonesia, it's a country with 250 million people. People don't understand what a browser is. They don't understand the concept of internet, but they are all the time in the internet using their phones. You know, you buy a phone for nothing, you buy 3 gigabytes of data for nothing, and you're constantly browsing through apps. So all the services from Google don't exist in that market, and it's a market as big as the United States. So this is the problem. People don't understand connectivity, but there is products where connectivity comes with the product, and everybody understands that they are connected, but they don't know how. It's like magic, right? Like the Kindle. The Kindle is always connected. You download a book, and the price comes with the book. You don't pay a monthly fee, at least on the original Kindles. Not from the beginning. It's like magic. So it's just there, included. If you look through the definition of it, connectivity is included. So for the IoT to succeed, connectivity needs to be taken away from the concept of device. This is one of the biggest issues. So let's talk about types of devices. So I like to categorize things in these subcategories. First, I like to talk about personal networks, and then about always-on networks. These are two different things. Personal networks are always going through a personal gateway, which could be the phone, for example. I carry my phone with me. I have a training device like Nike Plus or the Fitbit or Fuel Band or whatever. As you see, I don't have any of those, so I can't hardly say the names. Or whatever medical device, anything. Or I'm, for example, going to a gym, and there is a bike in the gym, and I plug my personal device to that device, and I set up a personal network for the time being, and when I leave, it disappears. Or I have sensors at my home, and then I connect when I'm home. So let's look at the examples of what people are building in the IoT without knowing it's IoT. And I'm going to take a couple of examples within the Arduino realm, because I think it's good to link both parts of my talk. So the first one is Sebastian, who at the age of 14 had the idea of connecting an earthquake alarm to an Arduino Ethernet that was tweeting every time it was detecting a vibration. So he got 32,000 followers in no time. I think he has over 300,000 followers right now. And has a small business where he has apps and stuff for different types of phones, and now has a small network of earthquake monitoring devices throughout the region. So this is an idea of something that is always on, that can report information to people that want to subscribe to it. I like to make fun of us geeks inventing things like this, which is, this is a very famous device. It's called the Botanicals, and it's a machine that tweets when your plant is lacking water. I can bet money that half of you guys see it as a very practical thing, especially because of the Ethernet connector that it needs to come all the way to the plant. As a concept, it's very interesting. As a realization, it's like super unpractical. Okay, I know the guy who made it, and he's a super sweet guy. His later inventions are so much better than this one. But conceptually, this trigger people's imagination. I think we are now over that phase. It's like this is like a 5 or 4 years old project at this point. This is part of, I think, it's MoMA's collection, actually, botanicals. They bought a couple of them. There are some other projects like the idea of Natural Fuse, which is a project where people are sharing electricity. It's the idea of like resources are not endless. So they create a fuse that is a plant. If the plant dies, the fuse is burned, so you cannot use any more electricity. So you have a certain amount of electricity you can use that is based on how much CO2 your plant can filter throughout the day. So if you use more of that CO2, you give less water to the plant. If you have less water, the plant is going to dry a little bit and slowly die, right? And the idea is that you can have your plant working in selfless or selfish mode. If you're selfless, you're giving away to the network, So basically, you give away your excellence, which means that other people will take from you, and they might eventually kill your plant by going funky. Or you can go into selfish mode, which means you're not going to give away anything, but you're going to suck as much as you can. So this is another very interesting conceptual piece by the same person that made the Patchway platform. I don't know if you're familiar with Patchway. No? I'm going to talk about Patchway right now. But he made this piece on top of the Patchway platform as a way to express this idea of sharing and how IoT could actually help people sharing at a different level in a very transparent way. He manifested the idea of consumption of electricity by killed plants. Another example of interesting monitoring of data is the Fukushima disaster. It's of course very sad that the thing happened in Fukushima, but there was a reaction from action groups, among others, makers all over the world. And the idea was that people weren't satisfied with the information they were getting from the governments, so a lot of people around the world started designing their own radiation counters and connecting them to the internet through Arduino, and monitoring their radiation. And they use an online platform that was open at the time. It was called PatchBay. Then it converted into something called Cosm, and then it changed name to something called Shibeli, and now it changed name again, and I don't know how it's called anymore. But basically the idea behind that platform is that you could connect any sensor and get graphs of your data online. Because one of the big problems on the IoT, if you have a lot of sensors, is how do you get access to that data? Where are you going to see that data? One of the problems is connectivity, but then beyond connectivity, what do you do with that information? If I don't want to share with you because I really am not interested in you knowing that, the temperature in my apartment is 21 degrees, because, it's so relevant, how can I look at that information by myself? How can I make use of it later on? So there's a lot of projects that are looking into this. For example, Smart Citizen is one of these projects that is building on this idea and is making a platform that has the whole ecosystem. It has the hardware, it has the UI, it has applications for you to monitor stuff. And the idea is that you can just, by using one of these boards, put them anywhere you want to, and you can decide whether you want this information to be private or public. If you want to share it, if you put it in your balcony, for example, you're sharing information about pollution, humidity, temperature, and so on with the rest of the city, and then make mapping tools to be able of looking at these different maps and so on. Cisco is very interested in this platform, by the way. So these are some examples of, always-on devices. It's an always-on device. I purchase it, whether it's my radiation counter, whether it's this thing, I put it on my balcony, and it's always on, and it's always sending data. But let's look at, through the arts, let's look into personal devices. This is an art professor from Norway called Ståle Stensli. He's completely worth getting to know as a human being. He's a really funny person. And I write papers with him. And I build things for him. So I think he's carrying in his hand is the equivalent to an Arduino Bluetooth board that can talk through Bluetooth to mobile phones. And the thing is that back in 2010, when Android changed to the Froyo is 2.2, right, in Android? Android developers, Froyo is 2.2? Yes. Thank you. Then it was the first time there was access to Bluetooth, but there was no easy-to-use library for developing on Bluetooth. So in my lab, we had the idea of developing a library we called SweetBlue, and with SweetBlue, you could quickly just drag the jar file in Eclipse and start typing commands, and it was like, light up the LED at the other side, and it was as easy as that, right? So with this, we could actually design a system that had 80 motors around your chest on a corset. And the idea was that you could represent different patterns of vibration on people's body, and the idea was that you will become the sculpture. It was not that you were going to see a sculpture park, it's that you were becoming the sculpture. And as you were walking around in the city, Google Maps would be triggering events that with different patterns of vibrations on your body. With some patterns, I can tell you can get completely seasick. If you make like certain things around, like this around your nipples, you get like, ooh, super funky. So we basically helped him developing this. We had like no idea at the point about this, but if you look into the idea of haptics and wearables, actually there's a lot of things that can be done, both for good and for evil. And so we helped them developing this platform. And at some point, he had the idea of porting this platform to like multiple devices. You could have multiple people around. And 80 motors is too big, so we made like a scaled-down version of something that had only 16 motors. Again, working on the idea of the personal networks. And so we made these jackets that he could move around. This is Oslo's main square. If you are from Norway, you might recognize it. And the problem was that I don't have the slide here because it's a public venue and stuff, but the police detained them 2 minutes later because you should not expose your electronics when you are making an art piece in Norway. But going back to the idea of personal networks, things that in 2011, at Google I/O, Google came out with the idea of making a prototyping platform for designers and engineers to create new accessories to Android devices. And it was completely based in Arduino. What this opened was the idea of creating these personal networks in everywhere you go. I explained you about the bike in the gym. The bike in the gym is a really good example where you basically, you have a device where you just plug in your phone to charge as you're exercising, and at the same time, it's gathering data of your exercise and storing it in your phone, and whether you want to share it or not is up to you. So it's a personal network. It only exists for you as you're there. It's very important because it's very different from the idea of you have a network that is always on. It's a completely different category. One of the biggest confusions we have right now in the IoT, besides the problem of not connecting to stuff, is that people don't understand what is an IoT device and what is not, because there is no proper categorization of the different types of devices. Just as a funny note, we can talk about the idea of self-monitoring yourself. I don't know if you ever saw this concept where this guy decided that it was very interesting to be checking where he was home or not and stuff. So decided to embed an RFID tag in his hand, just like that. So the question is, this is another question. It's actually, I put it as a joke, but you have to ask yourself, how far do you want to go? How easy you want to make it? It's it's not science fiction anymore. Technology allows to do all of these things. It allows to, identify ourselves, identify multiple devices wirelessly at fairly long distance. IoT allows this. So the question is, how far conceptually do we want to go? So I think one of the biggest things with IoT is that we are still trying to understand the real value of it. Oh, is a question?
There's more comments. There's a nightclub in Belgium that actually invoices the drinks if you have a chip in your hand or in the neck.
Do you get a discount? Because then I'm going to get it. No, but I mean, the point really is, how ready are we to accept many of these things? It's like, personally, I am one of the Arduino inventors. I have one Arduino board in my apartment. It's controlling my kitchen lamps because my daughter wanted to have a rainbow. So I made a rainbow light in the kitchen. So when she's having breakfast, she sees the rainbow passing by. But there is no more. As a technologist, I see technology all the time. And I don't really feel comfortable having it around me home for some reason. It's just me. The question is, as society, how ready are we to accept many of these things? And I think our mindset is going to change over time. I always make this thing, I always say this thing that in Spain, when I was finishing my studies, like 95, 96, mobile phones were already there. Having a mobile phone on your desk when you were having a coffee with your friends was unpolite. It meant that you were unable of disconnecting from your work because it was a working tool. Nowadays, if you're with friends and you don't have a mobile phone, you are a jerk because you can't connect with your friends. You can't talk to them. It's in the span of 5 to 10 years, our way of understanding technology has changed dramatically. So I think will come a time when not having an RFID embedded will be considered stupid, right? So the question is, how ready are we to change? But the problem is really that technology right now can't really allow to scale up to full scale. It's like if everybody in Sweden right now, to take a country, had 10 GSM connected devices, let's say using the machine-to-machine infrastructure, Telia says they couldn't support it. I was in conversation with Telia a couple of years ago, and they said, if everybody had 10 GSM devices right now connected in the cities, we wouldn't have enough antennas to carry all the communication this would generate. So the question is that this whole vision of 50 billion connected devices and so on still needs a lot of changes at the infrastructure level. So what are companies? Well, some companies are starting to look into this and make interesting proposals. I think one of the interesting proposals, most interesting or most practical one, is AT&T's Digital Life. It's basically giving you a bunch of sensors that you can put in your home. It's a camera, temperature sensor, fire sensor, whatever, or smoke detector. And it's a bundle that gives you for a fixed price in a month, even applications where you can monitor your life. And you might say okay, but Nest is also giving this to me, right? Yeah, well, AT&T comes to your place, installs it, takes care of it for you. You don't need to be a geek to have it, right? You can be the average Joe and have it. You can be Petter Nilsson in Sweden and have it. And this is the thing. It's like, for the IoT to succeed, we need a lot of steps to be taken, or a lot of steps need to be taken. The other day I was discussing with one of my designers that is actually born in 1980 something, really late, about the fact that in the 80s, we didn't own the phones. And she was like, what do you mean we didn't own the phones? I said, yeah, in the beginning we were renting the phones from the phone companies. We didn't own the phones because it was the best way for companies to give us support, because it was their device. They would take care of it. And if you were breaking it, you had to pay for it. I bet money that some of you didn't know this in this room, you know. Because when we grew up, suddenly we were allowed to buy other phones and plug them to the network. In the beginning, you couldn't even plug a phone that wasn't from the phone company in the network. Like my dad, that is a technician in telephony, he was importing phones from France and putting them home. And that was like special, you know, because you were not allowed to have those phones because they didn't exist for the Telefonica company. So we are at that stage right now in IoT. We need someone to really take care of it because it's so complex. There are so many pieces. So other companies doing stuff, for example, is Telefonica that tries to take a modular approach to the idea of creating connected devices. Like, I need a sensor and I need Wi-Fi connectivity, or I need a sensor and I need GPRS connectivity, or I need to run on batteries, or I could actually just put it on a power plug and let it run there. So they created this concept called Thinking Things from something called the Physical Internet Laboratory at Telefonica in Spain, where you can just plug devices as you need, and it's actually fairly cheap, I have to say. And then what happens with Arduino? Well, Arduino has a whole, you know, set of platforms depending on which are your needs. So we are focusing on people developing stuff that want to try out things. So we work from, you need like a small thing that needs Wi-Fi or Zigbee, to you need like a small computer like the one that says coming soon. It's like a Linux computer, could run Android eventually, that can have, it has an industrial form factor, has multiple USB ports, etc., right? For not talking about the collaboration that we're having with Intel about the Quark processors. They look like this, very nice. Oh, I need 30. That's cool. There will be time for a lot of questions because I'm like speeding up and oof, thank you. So, so then since I have a bit more time, I can make some fun about this particular situation. Because, I mean, I have to say, it's a blast to collaborate with companies like Atmel. I mean, Arduino, as a company, we are a 40-people operation in 7 countries. We are a micro multinational. In Sweden, we have 10 people working part-time. In Torino, in Italy, we have 16 people working full-time. In Bangalore, India, we have 4 people working full-time. And I could go on. So it's a very interesting operation because all of a sudden you get companies like Intel that come and say, we really love your hardware abstraction. And this is where it comes, the idea of the hardware abstraction. Because in this whole ecosystem of boards, we have a common hardware abstraction layer. We could completely change, you know, the technology underneath and make our system do something else, which is one of the basic aspects for connected devices. You need like a very simple way to design software for them. And independently whether you want the thing to work over GPRS or, you know, Ethernet or Wi-Fi, you just want to say, send this package to this direction. And then the rest will handle it. So companies like Intel got interested. This is Intel CEO. You will see him in a much funnier scenario later on in the day. And this is a Quark processor that is basically a processor that they are using to approach the IoT business. This is a system on a chip running a Pentium that on top of that has peripherals to allow doing interesting use of GPIOs, like having PWM to, you know, approach motors or analog inputs and so on. So when we met with them last year in London, they came, I mean, it was a very interesting situation. They just called us, we want to talk to you. You need to sign this NDA. We signed the NDA because when somebody like Intel calls you, sign whatever, you know. Even if it's for a cup of coffee, it's like, sign here. Yeah, sure. I'm right-handed, but I will sign with my left foot even, like this. And then we're sitting there in London, and they say, like, okay, we want to talk about this. And they put this thing on the table. I was like, what? It's like we recognize the Arduino form factor because of these connectors, right? And they say, like, well, I'm not going to tell you what this is, but I'm going to show you how it works. And they made an example, and it was just working fine. And like a typical Arduino code, like blink a light, or connect over Wi-Fi to something, or download this from the internet, parse it, and do like, it was like, wait, how are you doing that? And they're like, well, this is a Pentium processor, it's running an Arduino emulator. And since we have a hardware abstraction layer, they could make a simulator or emulator of the hardware abstraction layer that they could run on a Linux machine that then, could like have as much memory as you want to do super complicated operations and still talk to the physical level the same way we talk to the physical level. You can control the pins the same way you control them in a microcontroller, but you have a full Linux thing running there. So it's a very interesting concept. It's still not fully developed, I have to say, but it's very interesting. So we're like, great. And what do you want to do with this? And they're like, we want to give it away for free. It's like our hearts were like, it's like, okay, we're doomed now. And they're like, but we want to work with you. I was like, so, but obviously the idea, as you know, I mean, to me this goes back to some months before this meeting when I was actually making a lecture like this one at IBM Watson Center. It's the place where they made the Watson supercomputer, the one that competes against people on TV and wins and stuff, right? So I come with my idea of like 8-bit platforms. We talk about, yeah, guys, we're going to take over the world. And they're like, yeah, sure, man. We're making Watson, And they, at some point, they were actually impressed by the whole concept of community and how it's working, because it's working really well for us. And it says like, okay, how many processors are you putting out in people's hands? I'm sure, I was like, yeah, at this point, I think like 1 million chips. And they're like, at this point, they told me the truth, the world of embedded is taken by PowerPC. It's the most used processor in embedded in the world. And I was like, okay. I was like holding myself to the table. But the thing is, like, PowerPC is aging. And Intel wants to take a share of that. And this is what they want to do. They think Quark is a really good strategy. Personally, I think it's a good strategy. It has everything you need. It still needs to be polished, okay? The Quark processors that you see on the Galileo boards, they are the first batch of silicon. They have such an experience in designing that they didn't have to make a second batch. They made the first batch, they put it and it worked fine. It was like, okay, let's bring it out. It doesn't need cooling, doesn't need anything. So it's like you have a full Pentium without cooling, working at room temperature. No fan, no radiator, no nothing. That's pretty impressive in my eyes. But of course, I'm a hardware guy. I designed microchips before, So we basically had to make something fun. So for this particular event of launching the Galileo board, we made a boombox. So I told you we're going to see this guy in a completely different scenario later on. So here he's trying out the mixer board we made, where he would just put different sounds and stuff live and loop them and so on. It was kind of funny because some of the sounds were farts and burps, and I think that we captured his attention in the middle of a burp. But then around the concept of IoT, there is really a lot of things. There's different approaches. CLab from Spain is a company that unfortunately I think is kind of disappearing. I hope it's not, but I haven't heard of them for a while. I haven't heard of them for a while because they're actually making a zillion billions of money. But the approach of this company is, you can save money. That's the message for many IoT companies. You save money. And we install our sensors and stuff on city infrastructure, on street lights, light poles, anything. And we detect how much things are used. For example, we detect traffic on the street here, and if we see that there's a car every hour in the nights, we only turn on one of every other lamp. And the other night, we turn the other lamps on. So you save on the light bulbs. And you have a special event, you turn on all the light bulbs. And you save electricity. And they capitalize on people's savings. So that's the idea. We go to a city council, you can save 2 million euros, we want 30%. Who wouldn't fall for that? It's a good concept. It doesn't work for everybody. I already explained you about Sibeli earlier, which is Patchway before, which idea is basically to offer services to connect your stuff to the internet. Because as I said, what happens when you have your own devices that you purchase, you buy a Belkin temperature sensor for the IoT. How are you going to get that thing to talk in the rest of your infrastructure with your Samsung TV and your IKEA intelligent kitchen? How are they going to talk to each other? Well, you need somebody else's probably cloud services to make that happen. There are still room for smaller projects like Goodnight Lamp, which is a British project that came on Kickstarter or Indiegogo, I don't know anymore. The idea is a classic design project where dad has the big lamp and the kids have the small lamp. So when they are in different rooms, they can still feel the presence of each other. They talk through the internet and they transmit, the idea of being there. And you see, there's like many different approaches. There is like the wearable internet. There is the IoT. There is the always-on IoT. There is the one that is sometimes on, sometimes off, but only exists for you. But something that is very clear, the whole vertical looks something like this. And it's very complicated. So you need somebody that makes sensors and actuators. They need to talk to gateways. Somebody needs to manufacture this whole thing. You need a sales department that will put these things in people's hands. You need somebody that's going to deploy this thing. You need the cloud or some sort of backend to give service to your people. And then on top of that, you will build services like the classic IFTTT. If this, then that. IFTTT. Yeah, 3 T's. It's really early to say those acronyms for me. Remember, I'm from Spain. So, and then you have apps that get feeds from those services and give you what you need when you need it, right? So this is a very complex vertical, and very few companies in the world can handle the full thing. And shortcuts, like for example, Nest shortcut is, we make the manufacturing, we make the sensor, you deploy it, we have our own backend, and you have one single app. That is not sustainable in the long run, unless somebody comes in and standardizes this thing and becomes a de facto standard. So which are then the dangers? So I'm going to tell you now 2 stories that are true stories about the dangers that I find actually quite hilarious. So one of the stories has to do with this device. This is what we call the Arduino USM Shield that we designed together with Telefonica. Because Telefonica was very concerned about that many developers didn't have proper access to development tools for the M2M business. So they came to Arduino and said, okay guys, you really handle communities really well. What if we create something with you? And we work together with them making this shield. If you know anything about designing hardware, you make the shield in like 3 days, full time. Including having coffee every 20 minutes, and having chips in the meanwhile. Or apples, if you are green hacker style. But the thing that took us 2 years was the business model around connectivity, because I told you the big problem, the thing that needs to be hacked is connectivity. So we work with Telefonica and making a SIM card with international roaming. So if you design something in Spain, you can ship it to Germany, and they don't need to open the box to put a new SIM card. It will just work out of the box. And they just need to go online and pay their connectivity every 6 months, period. Making that available was very complex. It took a lot of time, and we did it. But then what happens is that actually some people make their own real products out of these prototyping platforms we make. And a company made a monitoring system with about 100 of these devices that they deployed on an area to monitor temperature and humidity and stuff from the field. And these devices were talking through GPRS towards a server. At some point, the server was off. So the machines were trying to make their PHP requests, and they couldn't talk to it. But the firmware was designed poorly. So instead of just noticing, okay, I have GSM, but I don't have connection to the server, they thought, I have no connection. And they had deployed some sort of like an Aloha protocol. As soon as the thing had no connection, randomly, a couple of seconds later, it was trying to connect again and to connect again. So they had 100 devices trying to connect again and connect again and connect again. And they didn't realize this for a week. So we're generating as much traffic as a small country. By having small, like relatively small, of just a couple hundred devices connected to this GPRS infrastructure, they generate as much traffic as a small country. So this is what I call the IoT vampires. What happens if you have deployed these kind of sensors in a whole neighborhood or in a whole city like Stockholm, which is over 1 million people? You will be probably putting down the whole wireless communication, if you have a similar situation. This is one of the dangers, that connectivity needs to be approached the right way. And also, it's always having to do with connectivity. The other case is the Navastak rabbit that you might know. Do you recognize the rabbit? No? Okay, guys, homework. This is the first IoT device in the gig environment. It was made in 2006 by a company called Violet. I don't know if it's Violet or Violet because it was French. And it was basically a rabbit that was reading your email, had text-to-speech implemented. It was like connecting to shoutcast radio channels and stuff like this. And you could control it through an interface. So the company had its own server. You will go to their backend and program which applications you wanted to run on this thing and program times and stuff like this. So the device itself didn't have that intelligence. It was the network that had that intelligence. What happens is that this company went bankrupt 2007, 2008. And then it was bought by somebody, and they came back to life 2010. And it got bankrupt and came back to life last Christmas. And so if you were hooked up to their servers and you had this device connected, imagine you, this device is just a metaphor, but imagine you buy 20 sensors for your house, and you have them around, and they are running on a battery or a solar panel, so they are on, but they don't represent anything to you because they are ubiquitous. They are there, but they are not there any longer. So they basically are, if the infrastructure can't handle them because the infrastructure is dead because the company I was running went bankrupt, you don't really care about them anymore, and you're not going to purchase any new of those. But if somebody revamps the server, then the thing comes back to life. So they are zombies. They are dead, but not dead. They're undead, So this is a zombie design. This is a zombie device. And has to do again with the problem of how you connect to stuff. So the Navastak, I can't say the name of this device, Navastak, is very complicated. Actually, it's called Navastak tag with double tag in the end, because it was generation 2. And it's kind of like that. We have it in our kitchen, and right now he sometimes sings something in French randomly. And then the other day, a server went back to life, so I was able of sending some stuff to the server, and it could talk to my daughter. It was hilarious, looking at her like, what? Is this thing talking to me, right? But most of the time, the guy's like off and he goes crazy and starts, resetting itself in the middle of the night. You hear him screaming in the kitchen, saying, it has this sentence that he says when he wakes up, like, hey, how was your day? How's your breakfast going? I spent the night running through the fields looking for carrots. This is, as I said, another danger. And you can explain these things from a more technical point of view and talk about random DOS attacks. You could talk about, but for me, it's really about vampires and zombies. It's like devices that, because of their nature, because of the complexity of the IoT ecosystem, they end up dying and coming back to life at some point. So the lesson learned here is that you need to build upon open structures so that if those companies die, you at least can figure out a way to help your users migrate in a smooth way. It's like if you have, nobody has really been thinking about this, but imagine that you run a company and you have an IoT network of sensors on a lot of people deployed in a lot of locations. How are you going to do remotely the transition of all these people to the next system without them having to press a click anywhere? That's really a big question. For us, it's based on the idea of having open everything. For some people, we just open APIs. But these are the things that need to be sorted out. So connectivity and openness are our recipe for the future. So that's all for me. Thank you very much. Do you have any questions?
Thank you. A great presentation. Thank you, David. We have some time for questions before the coffee break, so please raise your hand. I will run with the mic to you. Anyone? So no one there to start. Yeah.
Hi, Thanks for a good presentation. It was really good to listen to you. And my question is, all of these applications you show us, it's for the masses, for everyone to use. Do you know of any industrial applications, people using in, I don't know, power plants or industrial robots or something like that?
Well, that's a good question. We haven't really spoken about which is our, like in Arduino, which is our focus. Industrial hasn't been our focus yet because it requires a completely different level of certification. And we know people are using it, but usually when people are using it, they don't want to say openly we're using it. You know, like once I was giving a speech like this, and somebody from Iberia Land Services told us every Iberia truck in Barajas Airport has an Arduino board inside. I was like, what? I was like, can you send me a screenshot or something, picture? So it's like, no, we can really accept we actually did it with your thing. But it's basically, if you take the bare hardware, you certify yourself, you can do stuff, but we don't get any news about it. For us, it actually represents quite an investment because we try to keep the prices super low. So we have a hard time doing that. But we're looking into it. And when it comes to home applications, I think we will approach home before we approach industrial, because home from a purely market point of view, is easier. You need to fulfill like different electrical regulations with safety and about the housing of the devices and stuff, but it's not at all like the safety that you need on the other end. And just to close down on IoT, we are teaming up with a company called Tembu from the States that gives free service to our users on the basic, IoT infrastructure to trigger events. Like when this sensor goes at this temperature, put on Facebook, I am hot. It's like Tembu. But Tembu has also an industrial offering now. So we're trying to team up with people that can do these things, because we also understand that it's a very complex vertical and that we can't be everywhere. We try to focus on what we do best and try to team up with the best partners for each part of the process. Thank you.
Hi. I have a kid that's 8 years old, and she's a little bit interested in these kind of things. What would you do to get your kid interested in hardware and software, electronics and so on?
Well, my kid is already interested. She wants to be a magic animal veterinary. So we help her building a lab. No, seriously. What I do, I work a lot with kids. I have a personal interest beyond having a kid. I was before having a kid. Many geeks turn into kids when they get kids, but I've always been a kid myself, so I've been interested all the time. So what I do with my kid in particular, I sit with her and I tell her, what do you want to draw today? And she says, I want to draw a house. And it's like, how is the house? She says, it's yellow. So I open processing and I code a yellow rectangle. And she said, Daddy, that's not a house, that's just a rectangle. I said, what is it missing? It's in the roof. Which color is the roof? It's red. And I draw with code a red triangle and put it on top. And it's like, oh, but that has no door. And we go on and on like this. And at some point I say, what would you change? It's like, the house is too big. So I just go and tell her, you want to control the size? She says, yes. So we connect an Arduino board and we put a potentiometer, and I basically open up a serial port and let her control the size of the house. This is like a 2 hours process to build this house that you can change. But then she feels like she did it. When we look at the pictures I was taking that day when we were doing this particular, we made a lot of experiments like this. Then she was like completely in love with the idea that she thinks that she made the house. She thinks that she made a house, that she made a Halloween animation for a party we made, that she designed robots that, of course, she didn't even put a screw on them. But then she looks at the videos and it looks like she was doing it, right? So when they are very young, basically you have to make everything and make them believe that they are making it if you want to encourage them. But I would say don't force them either. If they don't feel completely interested, you will figure out something else. For latecomers, people, like kids in the age of 12 years old and stuff, like Minecraft is working really, really well. So we in Malmo have something called Kidscraft. It's arranged by a guy called Peter Neubauer. And Kidscraft is is an event where the kids come and play Minecraft. But now the CSOPs are kids that are 12, 13 years old. So then they start having meetings where they plan the next Minecraft gathering when the kids are building the network, right? And then they have another part of the event where they're 3D printing Minecraft objects. So they're slowly, bringing them into the technology by tackling upon what they're interested in. So the issue is like there is no, or I think the message is like there is no clear path. If you start early enough, you can figure out if, depending on when you're coming in, you need to work around the matter and figure out the best way. It's really a one-to-one operation.
Thank you.
Thank you.
Anyone else?
Coffee is very tempting, huh? Okay.
Okay. No one? No? Thank you again, David. Great presentation. Coffee will be served, I think it's outside here and also up in the exhibition area. So it's coffee until, I think it's half an hour at least, until 11 before next session. Thank you.
Thank you.
So, yeah, I've gotten a few of those Intel Galileos.